Hey physics. So I'm going to talk you through this Google form called the Small Dense Positive Nucleus. This is based on the nuclear model that Ernest Rutherford discovered with his gold foil experiment. And it is the third model of the ones that we're looking at, following the simple model, which had a solid sphere with uniform properties, which was then crumpled up and turned into the Plum pudding model, which says that atoms have charges. But it was thought that they had a positive fluff like a blueberry muffin and then negative electrons interspersed throughout like blueberries in a blueberry muffin. This model says that the nucleus, which contains, that there is a nucleus first of all, which contains all the positive charge of the atom as well as all of its, like nearly all of its mass. The electrons kind of like are around the nucleus, but we don't know a whole lot about how yet. So first question is, what is the biggest difference between the plum pudding model and the nuclear model of the atom? I would say something like that most of the atom in the atomic nuclear model is empty space. You can see that here this is all full of fluff, and this is like empty space with this tiny nucleus in there and these electrons which have almost no, I mean these are tiny, they have almost no mass floating around it. So really, I mean, if you really think about that, that means that all of these things that we think are solid are mostly empty space. How crazy is that? Your arm is mostly empty space. It's these atoms that are all put together, and it's all kind of looks the way that it does because it happens on such a small scale, but things are not as they appear, are they? So what happened when Rutherford focused a beam of alpha particles from a radioactive substance on a thin sheet of gold foil? Did all the alpha particles go straight through? Did they bounce off? Or did most of them go through but a few bounce off or were deflected? So most of them went through, but a few of them did bounce off or get deflected, and they were deflected by the tiny nuclei of those atoms. So most of the alpha particles went through, but a few bounced off or were deflected is the correct answer there. So what did the fluorescent screen show? So the fluorescent screen, remember these are radioactive particles. They're called alpha particles, which is essentially a helium atom with no electrons, 2 protons, 2 neutrons, and no electrons in this case. But if it was a regular helium atom, it would have 2 electrons to balance out those positive charges. So this fluorescent screen lights up wherever it's hit by an alpha particle. So it shows if they went straight through, it would all just light up straight across from the radioactive source. But what ended up happening is that those particles bounced off of the nuclei in those atoms. So they ended up, a few of them, I mean, you think about like how many particles are actually going through. About 1 in 10,000 bounced in a different direction, was deflected by one of those nuclei. Sorry, my 3-year-old FaceTimed me. So what did the fluorescent screen show? It showed where the alpha particles hit, like where they were deflected to. So why did most of the positively charged alpha particles pass through the gold atoms? Was it because of the force of attraction? Was it because of the force of repulsion? Or because most of the atom is empty space? It's because most of the atom was empty space. There's electrons in here, but the alpha particles are a lot bigger than the electrons, so they're going to go straight through most of the time unless they're hitting a positively charged nucleus. So Rutherford found out that most of an atom's mass is in the atom's tiny nucleus. What charge does the nucleus have? It's positive. It's got protons and neutrons in there. Neutrons, which you'll hear about soon, have no charge. They have a balanced charge. Protons have more positive. So the net charge of the nucleus, protons and neutrons, is positive. And then the number of electrons balances that out. So which subatomic particle gives the atom's nucleus its charge? Protons. This is my rendition of a proton. An alpha particle has a mass of 4 atomic mass units. An atom of gold has a mass of 196 atomic mass units, which has more subatomic particles in its nucleus. the gold particle obviously is just like giant compared to the alpha particle. So obviously an atom of gold is going to have more subatomic particles in its nucleus than the other one. So there you go. Those are the answers. See you later.